I'm gonna teach you how to test all types of SMD capacitors using the multimeter. But first, let's answer some questions. What is SMD capacitor? What are the types of SMD capacitors? What are the different symbols of SMD capacitors? How to calculate SMD capacitor codes? So let's see the definition of SMD capacitor. The capacitor is a component that is used to store electrical energy. It consists of two electrical conductors that are separated from each other by insulation material. The space between the capacitor conductors is filled by an insulating material known as a dielectric. The ability of the capacitor to store energy is known as capacitance. So as you can see here, this is basically the capacitor component. Here, as you can see, we have two electrodes. This is a metal electrodes, this black part and the red part, okay? And here we have a dielectric material or insulation material here, okay? And here, of course, this electron means energy because the capacitor has the ability to store energy, okay? So now let's see the characteristics of capacitor. So the capacitor has two nominal values, the working voltage V and the capacitance C. The capacitance value is measured in farads, F, and is marked onto the body of the capacitor. The capacitance is a ratio of the amount of electric charge stored on capacitor conductors. The capacitor has the ability to store electrical charge even when there is no circuit current flowing. So as you can see here, this is the capacitor here. This is an electrolytic capacitor, and here we have a tantalum capacitor. Basically, these two kinds of capacitors are polarized capacitors. So here, as you can see, over any capacitor you will find some numbers and letters. So for this kind of capacitor, as you can see, we have here 100. So the 100 means 100 microfarads. Okay, this is the capacitance and this is the voltage. So 50 means 50 volts. Okay, and here this is the date code. Okay, the date code. And for this capacitor, the tantalum capacitor, the same working principle. We have here 107, the capacitance, and we have here 16 volts. This is the voltage, okay? So the standard units of capacitance are basically three main standard units: the microfarad, the nanofarad, and the picofarad, okay? So 1 farad equal to 10 power 6 microfarads, and 1 farad equal to 10 power 9 nanofarads, and 1 farad equal to 10 power 12 picofarads. So right now, let's see the types of capacitors. So basically, there is three types of capacitors. So the SMD capacitors are categorized into different types based on the dielectric material used: electrolytic capacitors, tantalum capacitors, and multi-layer ceramic capacitors. Let's begin with electrolytic capacitor. So this type of capacitor is widely used, especially in computer motherboards, due to its low cost and high level of capacitance. The number marked above the capacitor indicates the voltage and the value of capacitance, but sometimes the code may not be understood easily unless you use the capacitance code table. So as you can see here, for this two electrolytic capacitor, so the code is clear and evident. We have 330 microfarad and 10 volts, okay, the working voltage. And for this capacitor we have 330 means microfarad and 35 volt. But sometimes you can find some electrolytic capacitor that has a strange code that you cannot understand easily. That's why we should use the code table. Okay, so as you can see here, for example, we have these two capacitors where we have the code or the value of the capacitance and the voltage clear and evident. And for example, we have this kind of capacitor, as you can see. So we have here 100. This is clear. 100 means 100 microfarad. Okay, and here we don't have voltage, we have just some letters. Okay, and here this is a lot number. So here, based on this letter, always the first letter here means the voltage. So we have here V. We should use the code table. So let's look for the letter V. We have here V means 35 volts. So here we have 35 volts. So this capacitor characteristics are 100 microfarad and 35 volt. So this is voltage code table. So G means 4 volt, J means 6.3 volt, A 10 volt, C 16 volt, D 20 volt, E 25 volt, V 35 volt, H 50 volt. So right now let's pass to the second capacitor, the tantalum capacitor. So basically SMD tantalum capacitor is a polarized electronic component with positive plus and negative minus terminals. It is widely used especially in computer motherboards due to the high level of capacitance compared with ceramic capacitors. So here we have many kind of tantalum capacitor. As you can see, we're gonna see of course how to read the code of this tantalum capacitors. So with the same working principle, you should use the same table, as you can see, where we have letters and voltage here. So for this, for example, we have 226 A. So this is 226 means microfarad, okay, and A here means 25 volt. Okay, so for this capacitor 687 microfarad J, so J means 6.3 volt. So we have 685 V. So V means 35 volts. So the characteristics of this capacitor is 685 microfarad and 35 volts. Okay, so we have here 447A. So A means 10 volts. Okay, so this is the working principle of how to read the code of electrolytic capacitors and tantalum capacitors. Now let's pass to multi-layer ceramic capacitor. Multi-layer ceramic capacitor. A multi-layer ceramic capacitor, MLCC, is a fixed value capacitor. This type of capacitor is generally used in electronic circuits where small value capacitors are needed. It is constructed of many metal layers acting as the dielectric Its purpose is to regulate the flow of current in a circuit and prevent electromagnetic interference between electronic components. So as you can see here, this is basically the picture of a ceramic capacitor here, okay? The ceramic capacitor is no polarized capacitor, okay? So here we have a cross section of a ceramic capacitor. As you can see, it is composed of many layers, as you can see here. The insulation material between layers, okay? So here, as you can see, we have the ceramic capacitor terminals, okay? This is terminals, okay? Exactly like this. And of course here, this is the metal electrode, okay? And here, this is the dielectric or insulation materials. So now I'm going to show you how to calculate the ceramic capacitor code. So using the same working principle as the resistor. So the first and the second digits are fixed numbers, okay? The third digit is the multiplier. Okay, so the third digit is the multiplier. But for the ceramic capacitor, the fourth digit or letter is the tolerance. So if you find J means 5%, okay, K 10%, M 20%. See an example. For example, let's say we have a ceramic capacitor with 104K. So this code means 10 and 4 zeros, as you can see. So plus or minus 0.1 microfarads. So 0.1 microfarad, as you can see, is the tolerance, because here we have the K, so K 10%. Okay, so 10% of this number. We have here three numbers, so always, as you can see, the first digit, the second digit, and this is the multiplier. But if we have four digit, as you can see here, so the first digit, the second digit, we have the multiplier, the digit number 3, and the fourth digit is the tolerance. Okay, the tolerance, this digit have to be J or K or M. Okay, here we have some examples. So we have 1, 0, and 4 means, as you can see here, 100 picofarad. Okay, here we have 4, 7, 3, J, so means, as you can see here, 47,000 picofarad. Okay, and J, the tolerance is 5%. Always the ceramic capacitors are measured with picofarad. But for the electrolytic capacitors and tantalum capacitor, the unit is microfarad. But for this capacitor, the ceramic capacitor, the unit is picofarad. Okay? So now let's see the symbols of capacitors. So basically there is two types of symbols. Symbols for polarized capacitors and non-polarized capacitors. So as you can see here, all the symbols are the same. So here, this is a symbol for a polarized capacitor, for an electrolytic capacitor. Here we have plus and minus. Okay, always the top terminal is the plus. Here we have plus and minus. So this is plus and this is minus. This is the positive terminal and this is the negative terminal. Okay, always the top terminal is the positive terminal. Here, as you can see, we have plus and minus, and here this is the positive terminal and this is the ground terminal. Basically, these two symbols, these symbols are a U key symbols, and those are a US symbols. Okay, so but for the polarized capacitor, we used usually this two kind of symbols, this and this. Okay, for non-polarized capacitors we have these three symbols, but we used usually these symbols, as you can see. So this is also a UK symbol, and here this is a US symbols. So but we use this usually. So as you can see, this three samples doesn't have the plus and minus sign, okay, because those are no polarized capacitor. So now let's see how to test capacitor. Of course, before diving into testing capacitors, I want just to add that the capacitors, as you can see, for the polarized capacitors, you should respect the polarity. I mean, you should always put the red probe of the multimeter in the positive terminal and the negative probe or the black probe here in the negative terminal, okay? But for non-polarized capacitor, you can use the probes as you want. You can put the black hair and the red hair, or the red hair and the black hair. So let's see the capacitors. I'm going to show you how to test and check the capacitors, all kind of capacitors. Okay, so let's get started. So I will show you how to check capacitors using two methods. The first method is by selecting the diode option, and the second method by selecting the capacitor option. Okay, so let's begin with the first method by selecting the diode option. Okay, so here we have a tantalum capacitors that we're gonna check. So to check this capacitor, basically we should determine the positive terminal. The band means positive terminal. So let's check. So as you can see, we have a reading in the multimeter. So the value increase and decrease means the capacitor charge and discharge means this is a good capacitor. Okay, if you get a continuity or a buzzer means the capacitor is bad. So let's check this capacitor also. This is an electrolytic capacitor, so let's check it using the same working principle. So we have the value in the multimeter increase and decrease means the capacitor charge and discharge means this capacitor is good. Here also we have another tantalum capacitor. So as you can see in the multimeter, the same, we have a reading here that increase and decrease means this is a good capacitor. Okay, so let's check also this electrolytic capacitor. So let's check. Okay, here we get a reading in the multimeter that increase and decrease, as you can see, means this is a good capacitor. Now let's pass to the second method by testing the capacitance of capacitors. Okay, now we choose the capacitor option. As you can see in the multimeter, we have a nanofarad, but we have here auto range. Okay, so the multimeter will check automatically the capacitance without selecting a range. So let's begin with this capacitor. We have 220, as you can see, 220 microfarad. Okay, 220 microfarad. So we should get 220 microfarad. But sometimes we cannot get exact value. We have 220, about 220. We have 249. So this is a good capacitor. Okay, because you cannot get the exact value. Okay, so here as you can see the unit change automatically to microfarad. Here let's check this capacitor. We have 227 in the capacitance, 227. So as you can see in the multimeter, so we have about 227. We have 249. It's okay. Okay, so the capacitor is good. If you get a continuity or you hear a buzzer, means the capacitor is bad. So let's check this capacitor. Also we have 220. Its capacitance is 220 and 6.3 volt. So let's check. Always you should respect the polarity of the capacitor because the capacitor is a polarized component. Let's check. Good. We have, as you can see in the multimeter, about 220. This is a good capacitor. 226, good. This is a good capacitor. So as you can see here, for this capacitor, we have 220 and we have E. We don't have a voltage, but we have E. But for this, we should use the capacitance code table. The E means 25 volts. E refers to 25 volts, as you can see in the code table. But in this capacitor, for example, we have the capacitance and voltage. So let's check this capacitor. Also, we have here 110 volts, so we should get 100 microfarad in the multimeter. So let's check. So we have 91.4, about 100. This is a good capacitor. So now let's check the ceramic capacitors, okay? Using the same working principle, you should get a value in the multimeter. The value increase, as you can see. We get a value. Means the ceramic capacitor is good. If you get a continuity or a bezel, means the capacitor is damaged, is bad.